never intersect, right? Oof, wow, that's way too fat. We want them to be in the same plane. Okay, so we have parallel. Okay, and they can go that way, they can go this way. Just they never touch. Okay, and just because we're going to get to this at some point, parallel lines have the same slope. Okay, now skew lines are a little different. These are lines that never intersect. Bless you. But they are not in the same plane. And they don't necessarily have the same slope. They can have the same slope, but they don't have to. Okay, so this one's a little bit strange, and I can't really draw it very well. So what I'm going to do is I'm going to use markers to show you what I mean. Okay, so again, like on the box, the different sides of a box, opposite sides of a box are parallel planes, because they would never meet. So if you look at a box, each side has one side opposite it that's parallel, because they would never intersect. Or if you think about two pieces of paper, if you hold them up in space, the space between them, as long as there's space between them, they're parallel. But this is not, obviously. Questions on those, though? Okay, so we have this triangular prism, and we want to talk about all the segments parallel to JP. So first I find JP. Here's JP. So parallel to JP are going to be running along the same direction but never intersect. So these two lines. So I've got KQ and LR.
How about RQ? Would that be? No.
Sorry, these should have lines over top of them. Okay, so I have KQ and LR that are parallel. So parallel runs in the same direction. Okay. Now, if I say a segment skew to KL, so if I look at KL, yeah, let me just get rid of the highlighting. So KL, and so we said which ones? KQ won't be skew because KQ is going to intersect at K, right? Yeah, QP, because it'll never intersect, but it's not parallel, and RP. We have one more.
LJ? Or LJ?
JP. So if we look at these other lines, LR and KQ intersect, right? So it's not those. KJ and LJ also intersect. So it can't be those. And then RQ is parallel. So it has to be the lines that aren't parallel but don't intersect. So we have RP, QP, or JP. And you'll notice that the skew lines are kind of on the opposite side of the prism, and we have the opposite being the bottom and then opposite being the other end. So skew lines are kind of away from the line we're looking at. Okay. a plane parallel to plane PQR. So PQR is this plane right here. We have one plane parallel to it. And we want to try to keep the letters in the same order, so we went PQR, so we're going to go JKL. If we look at the other planes, we have this plane here, like the back of the wedge, but that intersects. And then all of these three sides basically would intersect with the plane we're looking at. So it can only be the one plane that's floating on top that doesn't touch.
Doesn't touch
the bottom.
Okay.
So we have all of the segments that are skewed to BC. So I'm going to first highlight BC. Okay. FG is going to be parallel because it runs in the same direction. So yeah, HG will work. HD will work. Mm-hmm. HE will be parallel because you see how it runs in the same direction. So even though we don't see that plane, there's kind of like a diagonal that can go between them. AB will intersect. So here, hold on one second. These lines all intersect, right? They all touch BC, so it's none of those. And then these lines all run in the same direction, so it can't be those. So we found them, the four yellow ones. So if we go here, we have AE. And again, I apologize, these should have lines over them because they're segments. So we have AE, EF, HG, and DH. Or H, you could flip the letters around too, that's okay. Does that make sense? All right, if we come back now, we say a segment parallel to EH. So if I'm looking at EH, I'm looking for all of the segments that run in the same direction. So we have AD, BC, and FG. Okay. Any questions about that one? Okay, well, we want to look, okay, DCH, we only need 3 letters to identify a plane, right? So these are the 3 letters, but it's really talking about this whole side.
Can you write down the 4 letters? Just so
you can write down the 4 letters if you would like to. So you could call this DCH, oops, wrong pen, DCHG if you want to. You have to have at least 3 letters to identify a plane, but you can use more than that if you want to. So if the 4 corners makes more sense to you, that's okay. We can add those.
So the only one you can identify is E, A, B, F.
Mm-hmm. So we could call it all 4 letters if you wanted to. Or you could call it EAB or ABF or EBF. So I've done those 3. AEF. Okay, so that's all the ways I could name it. And then, of course, those letters could be rearranged in any order. This is all the same plane. Okay, so we're talking about the top here. That are parallel to DEH, that's this side of the box. So I can call it by all 4 letters. B, C, F, G. Or I can use just any combination of 3 letters. So I could use B, C, and G, G, C, and F, or B, F, and G. And those can be in any order. So if you had them in a different order, that's okay as long as the letters are the same. Number 2, all segments parallel to AB. AB's right here. So what'd you guys get? Anybody?
Sorry, number 2,
EF?
EF,
Uh-huh.
DC, HG.
Yep. And if you had the letters flipped, so you had like FE or CD or GH, those are the same thing, so it's okay. With segments and planes and lines, the order doesn't matter. Number 3, we're looking at all segments that intersect GH. So here's GH. Ooh, ugly color. Let's not do that. Let's do red. There's GH. And we want everything that intersects GH. So we want everything that touches GH.
Oh, F, G, and E, G, H.
Uh-huh.
What about D, H, and C, G?
Yes. So we have EH, FG, DH, and CG. Or GC. Like I said, the order doesn't matter. And then number 4, we have all segments that are skew to CD. So we're looking for the ones that don't intersect but aren't going the same direction. Do you guys need me to highlight them?
I got EF, GA, AB, GH, BF.
Okay. Well, actually, GA could kind of work because it's diagonal through here, but we're going to try stick with the ones that they're showing us. You said GH?
Yeah.
Okay, GH runs the same direction. Do you see that?
Oh.
So EF is the same thing?
So EF is the same thing, yeah. So anything that runs in this direction, like AE will work.
So AB?
AB runs the same direction. Do you see that?
Where?
Here.
Oh, okay.
Yeah, so EF and HG and AB all kind of cut across the same direction, so those won't work.
BF?
BF works.
AB?
AB, AD. AD intersects. Okay, we're looking for this line. Yeah, sorry about making them all the same color. I think I got confusing.
That's that one too.
There's this one, this one, this one, and that one, yeah. So when you look at the box, so here's the box, right? If this is CD, it's the back of the box, those two, that don't intersect. You kind of get like L's. You see like an L here and an L here. So we'll list those. AE, EH, BF, and FG. But a transversal is a line that intersects two other lines. Okay, so this is my transversal. Because it's intersecting the other two lines. Okay. Interior angles are on the inside of the two lines being intersected. Okay, so if we look at this, I'm going to make the interior yellow. So all of the angles in here, this is the interior. So these are my interior angles. Okay. There are 4 of them. exterior angles are on the outside of the two lines. Okay, so if my interior was yellow, I'm going to make the exterior green. So all of this out here is the exterior. And I have 4 exterior angles. Okay. Consecutive interior angles. When you talk about consecutive, you're talking about coming in order, right? If we number things consecutively, we go 1 and then 2 and then 3 and then 4, 5, etc. So consecutive interior angles are on the same side of the transversal on the inside. Okay, so I'm going to circle those. We have 4 and 5 are consecutive interior angles. Let me do that way. Let me just list them. Angle 4 and angle 5 are consecutive interior because they're on the same side. And then we have angle 3 and angle 6. So you have 2 pairs of consecutive interior angles. Alternate interior angles are on opposite sides of the transversal and on opposite sides of the interior. Okay, so if we look at angle 4 is alternate to angle 6. They're on opposite sides of the transversal and on opposite sides of the inside. Does that make sense? So we have angle 4 and angle 6. And then see how angles 5 and 3 are also kind of on the opposite. So angle 5 and angle 3. Did not give myself enough room, did I? Okay, alternate exterior angles are kind of like alternate interior angles, except they're on the outside. So on opposite sides of the transversal and on opposite sides of the exterior. So angle 2 and angle 7 are alternate exterior, and angle 1 and angle 8. And then corresponding angles are the last kind, and these are in the same position. And in order to label all these, I'm going to draw another picture on a blank page and label it, okay? Did I? Where? Oh, opposite. Opposite. That's my new math word, opposite. Oh, whoops, way too big of an eraser. This is why I teach math and not spelling. Opposite. Better? Explaining corresponding angles, but like I said, I'm going to draw it bigger. Do you guys remember that game Foursquare?
Yeah.
Do you see how you've got 4 squares here? Like 1, 2, 3, 4, and 1, 2, 3, 4. So if this is the number 1 position, this is in the same position, like the top, left corner, top right corner, top right corner, bottom left, bottom right, bottom right. Those are corresponding because they're in the same relative position in the squares. So like I said, I'll go over that a little better when I draw it again. So I have I have 2 lines and a transversal. Okay. I'm going to use 8 different colors. So I'll have yellow here, and I'll have green here, and I'll have red here, and what do you say, purple? That's not a very bright purple. Let's do, I'll have a better purple. Okay. And hot pink and blue. How about brown? What do you think? Orange or baby blue or gray? I already used purple. Okay, fine. Orange. That's not too close to red, is it? Okay. So we have our angles, right? We have interior angles. And we have exterior angles. Okay. Our interior angles are red and blue and purple and hot pink. These 4 on the inside. Okay. Oh, by the way, if you want colors, I have a whole box of markers on the shelf. Help yourself. Or you can use numbers. Okay. Our exterior angles are yellow and green and brown and orange. Okay. So inside, outside. Okay, alternate interior and alternate exterior. Red and blue make a pair of alternate interiors. So this is a pair. And pink and purple make a pair of alternate interior. And then I have yellow and orange or alternate exterior, and green and brown.
Oh, and then they would go across.
They make like an X to be alternate exterior. So alternate being on opposite sides and on the outside. And alternate is opposite sides on the outside for exterior. And then on the inside, you have alternate interior. So they're interior angles, but they're on opposite sides. So they make like an X. Okay, consecutive angles can also be called like same side interior. They're the angles that go in an order as you go. So you have pink and red, blue and purple.
So you have to go over the line?
It's alternate.
Consecutive?
Yeah, consecutive is inside but next to each other. Okay, so red and pink make a pair of consecutive angles, purple and blue.
Corresponding would be yellow and brown?
No. Okay, when we look at corresponding angles, they're in the same position. So like if I were to take and draw a square around this, and if I were to draw a square around this, okay, corresponding angles are in the same position in that square. So top corner, top corner. So yellow and pink go together. Okay. Green and blue go together because they're in the top right-hand corner. Red and brown go together because they're in the bottom left-hand corner. And then purple and orange go together because they're in the bottom right-hand corner. So corresponding angles, like I said, if you draw kind of an imaginary box around here, they're in the same position in the box. So this one's in this position in the top box, so purple's in the same position in the bottom box. Those are corresponding. We're going to classify these angle relationships. So if I look at 1 and 5, so I'm going to start with just 1 and 5. Okay, in order to do that, the first thing we want to do is we want to identify the transversal. This is my transversal. Okay, so these are the two lines that I'm looking in relative to. We're on opposite sides of the transversal. We're outside the lines, so these are alternate exterior. Okay. It's too small. Too big, too small. Okay. If I want to look at 6 and 7, 6 and 7, they're on the interior and they're on the same size. So those are consecutive. Oops. Having trouble managing my pens today.
Are they consecutive?
6 and 7 were on the same side. On same side of the transversal on the inside makes them consecutive. Okay, if I look at 2 and 4, again, if I were to draw those kind of pretend boxes around here, do you see how they're in the same position in the box?
Yeah.
So those are corresponding. Okay, if I look at angles 2 and 6, they're on opposite sides of the transversal and on the inside, so they are alternate interior. Three and 7, opposite sides of that transversal on the inside, so those are also alternate interior. 5 and 7, if we look at the squares, they're in the same position, so corresponding. 4 and 8 are on opposite sides of that transversal and they're on the outside, so they're alternate exterior. And finally, we have 2 and 3. 2 and 3 are on the same side. Yeah. You sure?
Is it when it's on mine it says it's corresponding when it's like 2 and it crosses say over 5?
Okay, corresponding is when you kind of draw the square around them and they're in the same position. So 1 and 3 are corresponding. 8 and 6 are corresponding. 2 and 4 correspond, and 7 and 5. So corresponding are in the same position in the square.
Okay.
Does that help?
Uh,
See how these are both in the top corner, and these are in the same position. Those two are in the same position.
yeah.
Okay. That's how we know corresponding.
An alternate interior.
Alternate interior, you look at the transversal. So if I were to, let's just say, I'm going to highlight the transversal red. This is the transversal, right? So we look at the transversal. Alternate is on opposite sides of the transversal. So alternate interior, you've got 7 and 3 for alternate interior to each other. And then the other pair
They're across from each other,
is
right?
2 and 6. Yeah, they make an X like that. Okay? All right, so sometimes more than one line can be considered a transversal. And so when that happens is you want to identify the transversal for the pair of angles you're talking about. Okay, so for example, if I'm looking at angle 1 and angle 3, so in this case, this angle and this angle, angle 1 and 3. Right? Yeah, because I've got these two lines and this one line, the transversal is going to be the one line. So in that instance, yeah, H is going to be my transversal. Make that a different color. So for here, H is the transversal between 1 and 3. Once I've discovered which is the transversal, then I can look at their relationship around the transversal. So they're on opposite sides of the transversal, and then they're on the exterior of these two lines that are being intersected. So they're alternate exterior. Okay. Then I go and I look for my next pair. In this case, 5 and 6. Here's 5 and 6. 2 lines, 1 line. So K is my transversal. And they're consecutive because they're on the same side on the inside. Yeah. Okay.
Is that on the same side, right?
Yeah, they're on the same side and on the inside. That's what makes them consecutive. 2 and 6. Here's 2, here's 6. 2 lines. That makes L my transversal. Well, one's on the inside and one's on the outside. Yeah, but remember if I put those squares around them, see how they are both in the same corner? So these two are going to be corresponding. Okay, and then I'm going to look at 3 and 5. So here's 3 and here's 5. So here's my 2 lines. So J is my transversal. They are on the outside and opposite sides. So they are alternate exterior. And then finally, my last pair for this set are 7 and 5. Here's 7, here's 5. So these are the 2 lines being intersected. K becomes a transversal again. And you see how they're in the same position, kind of like in the X? They're both in the bottom of the X. So since they're in the same position, they're corresponding.
What if it was like 8 and 2?
8 and 2 would be alternate interior. Because they're both on the inside of the 2 lines, but on opposite sides of the transversal.
What about like 8 and then 4?
You don't have a relationship between those two. Because 4 can either be between these two lines with this transversal or between these two lines with this transversal. 8 is between these two lines with this transversal or these two lines with, but see how they don't have the same two lines and the same transversal in common? So 8 and 4 have no relationship. They have to have the same set of 3 lines in common for them to have a relationship. Does that make sense? Okay. Oops, that's not what I meant.